Today, we are diving into one of the most fascinating challenges in artificial intelligence. What happens when you try to fuse two expert AI brains into one? Well, it turns out the answer is often a complete disaster, and we're going to explore the incredibly elegant solution. All right, let's kick things off with a huge idea. Imagine you could combine an AI that's a brilliant poet with another that's an absolute genius at writing computer code. The dream here isn't just to have two separate specialists on hand, it's to fuse them together, to create a single powerful multitask model that can do both, all without having to retrain it from scratch. Now, you might think the obvious approach is simple enough, right? You just take the internal programming of each model, what researchers call their weights, and kind of average them out. But here's the kicker. That simple idea almost always fails. And not just fails a little, it fails spectacularly. Instead of getting the best of both worlds, you get a catastrophic drop in performance. You basically break both models in the process. So what is going on here? Why does this happen? Well, the core issue is a phenomenon that scientists call parameter interference. The best way to think about it is like a fundamental communication breakdown that happens when we try to merge the knowledge from two different AI brains. So this interference, that's the culprit behind the whole catastrophic failure. But what researchers found is that the problem wasn't just one big messy issue. It turns out the interference actually comes from two very specific hidden saboteurs that are ruining the merge every single time. So on one side, you have what we can call the noise. This is when a few really crucial updates from one AI get completely drowned out by a sea of tiny, irrelevant updates from the others. And then on the other side, you've got the civil war. This is where the models are literally fighting each other, pulling the same internal setting in opposite directions and just canceling each other out. And this really gets to the heart of that noise problem. You see, research shows that when an AI learns a new skill, only about 20% of the internal changes it makes are actually important. The other 80%? That's just background noise. Small, redundant changes that just get in the way. And what about that civil war? Well, it gets way worse the bigger you go. The more models you try to merge together, the more these internal tugs of war happen. So simply adding more AI brains just adds more chaos to the system. Okay, so if throwing more models at the problem just creates more chaos, how in the world do you fix it? How do you overcome both the noise and the civil war? Well, researchers developed this really elegant three-step solution they call ties merging. And the process is just brilliantly methodical. Okay, first you trim. It finds and completely resets that 80% of noisy, useless changes, leaving only the most important updates. Second, you elect. To stop that civil war, it looks at every single setting and basically holds an election to decide on one direction, either positive or negative. And finally, you merge. It combines only the updates that voted for that winning direction, completely ignoring any of the dissenters. It's so clever. So the big question, of course, is, does this beautiful theory actually work in the real world? I mean, how does it stack up against other methods when you really put it to the test? Let's take a look at the data. Researchers put ties through a really tough test, seeing how well the new merged model could handle completely new tasks it had never seen before. And while, the other methods show some okay gains, the results for ties merging, well, they're in a completely different league. In fact, ties merging didn't just win, it absolutely dominated. It showed a massive 4.4% absolute improvement over the strongest competing method. Now, in the world of AI research, a jump that big isn't just an improvement. It's a straight-up breakthrough. So, a 4.4% gain is super impressive on a chart. But what does a breakthrough like this actually mean for the future of AI? And, for us? Well, what it means is that we can now create these powerful, multi-talented AIs way cheaper, faster, and more effectively than ever before. Instead of needing dozens of specialist models, developers can now create one efficient generalist. Ties merging has basically solved a fundamental problem that held back progress for years, and it's giving builders a powerful new tool for creating the next generation of AI. And that leaves us with a final, really provocative thought. By successfully combining different AI skills, we're not just improving them, we're opening the door to creating entirely new capabilities. I mean, what happens when you merge an AI that understands music theory with one that understands quantum physics? We honestly don't know yet, but for the very first time, we have a reliable way to find out.